are learning about the algebra. Okay, so this is all related to the expression. Okay, so when we were dealing for expressions, then we definitely go for polynomials. Okay, so this is a basic thing where the mathematical expressions will be made up of. Okay, so as you know that polynomial means so many terms so will be there in the equation. Okay, so a numerical expression so which is written in terms of like so we may have terms and then variables and then everything so in an expression. Okay, so the example of polynomial is f of x equals to so like 4x cube plus 3x square minus 2x plus 1. Okay, so this is an example of a polynomial equation. So you know all these things. Okay, so here why we are discussing about this polynomial. So we are doing all the operations in the MATLAB so simple. Okay, so we are dealing with matrices, functions, and everything. So which is so difficult to do it in a do it with the hand. Okay, so if you go for addition, subtraction, multiplication of polynomial equations, so that is also takes a lot of time. Okay, so to reduce the time, so here the MATLAB will provide you the way of doing the MATLAB, the polynomial equations, dealing with the polynomial equations. As you know, so there are so many terms in the polynomial equation. So first, just let us know about the vocabulary. So just recall it once. Okay, so you may know that, but even though, so we'll see. Okay, so here we'll use variables, coefficients, and the terms. Okay, so and the constants also be there in a polynomial equation. Okay, so if you go for a variable, so whatever we'll use a letter. Okay, so for representing in terms of the definition of an expression. So here we'll use like a letter. Okay, so to represent the changing value, so this is also known as a variable which we'll use in the polynomial. And then here the coefficient. Okay, so the coefficient is a number. Okay, so which we'll find in the beginning or before the variable. Okay, so which will define the relationship. Okay, so obviously 4x is multiplies. Okay, 4 multiplies x. Okay, so here each and every portion of an expression to be treated. Okay, so while we were dealing with a polynomial expression, so if you go for the MATLAB also, if you wanted to represent them in a MATLAB also, so we need to take each and everything. Okay, and then the constants. Okay, so whatever we'll find at the end. Okay, end of the expression like +1 or -10 something. Okay, so it depends on the expression so which we were so dealing with. And then here the constant will also be there. Okay, so general polynomial examples you may have like -6x square plus 4x square minus x, and it's up to the representation. Okay, so how much will take the degree. Okay, so here we can say the degree as the biggest exponent which is there in a expression. Okay, so here 3 is a biggest exponent which will use as a highest degree of this expression. Okay, so when we deal for as you know that there are in the polynomial there are many forms. Okay, so as you know that there is a types like monomial which is like linear equation. Okay, so 2x plus 10 is equal to 0 is a simple example. So like in the form of ax plus b. Okay, it is also a polynomial expression, but here so it is in a linear fashion. Okay, so where there is only one variable which is will use for in term of representation of the equation. Okay, and then so if we go for binomial means so we'll also call it as a quadratic two equations. Okay, so where polynomial with two variables. Okay, so polynomials with two variables will be like 2x square plus 2x plus 2. Okay, so this is quadratic equation, so which is also known as binomial. Okay, so this is also another form of polynomial equation. And when we go for trinomial, so our cubic equation. Okay, so which means so we need to use three variable term. Okay, so like x cube plus 2x square plus 3x plus 5. Okay, so in terms of this, so here the cubic one which we have defined. Okay, so where so we may use three quotients here. Okay, so 1, 2, and again 1 in such a way, so you'll get three quotients. Okay, so and when we go for a polynomial equation, so here the polynomial with more than three variables will be treated as a polynomial. Okay, so as you know that it will be represented like a power n, sorry, a n x power n plus a n minus 1 x power n minus 1 a n minus 2 x power n minus 2. So in such a way. Okay, so in such a way we will represent. Okay, so until unless you get a constant. Okay, so equals to 0 in such a way, so you'll define. Okay, so the polynomial expression will be above the 3. Okay, so we can say as an example like 4x power 4 plus 2x power 3, it is 2x power 3 plus x square plus 5. Okay, So this is the way we will represent the polynomial equation. So this is all about the old one. Okay, so old where we were writing and learning about the algebra. Okay, and then we'll find the roots and everything. So when we wanted to perform the operations. Okay, so when it comes to the MATLAB. Okay, so when it comes to the MATLAB, so as you know that in the form where so we will use the representation of the polynomials by using vectors here. Okay, so we have vectors, vector representations, so that so we can easily define the polynomials. Okay, so here first we need to see how to represent the polynomials. So with the vectors of coefficients. Okay, first we need to find out the coefficients. Okay, so as you know that we need to find the order of the polynomial first. Okay, so if we take an expression like where we are, so if you go for an expression like f of x is equal to x power 4 and 2x power 3 plus 7x plus 3. Okay, so here we need to first find out the order of the polynomial first, or degree. Okay, so we need to find the degree. So based on that only we need to take the representation. Okay, so when we were dealing with vectors. Okay, so here for each and every representation of vectors or coefficients, so first we need to see the order here. Okay, so this is of 4. Okay, the degree of 4. So in the form of x power 4, x power 2, sorry, x power 3, x power 1, and x power 0. So would be the representation. So when we were going for the vector coefficients, so in the MATLAB. Okay, so and so when we were having an expression, so we need to first see the highest degree, and then so based on the highest degree only we need to define the coefficients. Okay, so if we have like 4, 3 is there, but 2 is not there, and again 1 is there. So for the place of 2, we need to fill the vector with a 0. Okay, that is a thing we need to first observe. So while we were creating a coefficient. Okay, so coefficient related thing in the vector. So if I wanted to go for creation, so in the so in the polynomial, see it is an example. P is equal to, as I said that it is in the form of vectors. Okay, so if I wanted to make it as like the equation, polynomial equation, then definitely, so I need to take the coefficients. Okay, so coefficients, and then I need to follow the order. Okay, so order, based on the order, I need to create the polynomial expression. So can you find the expression here? Okay, so what is the expression here? So 1, 2, 3, 4 is an 4 is an order. So means highest degree will be 3. So here you can write the expression by seeing the vector of coefficients. So ella raskar cheppandi. So x for cube. So you can see 1 is the coefficient of the highest degree. So which is 3, 3, 2, 1, 0. So is an order. Okay, so polynomial order. So when we were going to define the polynomial expression, so in terms of the vectors of coefficients, definitely we need to find the order of representation. So while we are creating a vector. Okay, so here you can easily write this. Based on this, you can easily observe, you can easily create the polynomial expression f of x equal to x cube minus 1.5 ఏమొస్తుంది చెప్పండి, b active x square minus 5.5 x plus 3. Okay, so plus 3 is a constant where we were using the number here. Okay, is it clear everyone? Coefficients and then constants, so where you can represent it in a form of expression. Okay, so ఇక్కడ నేను x power 4 minus 2x cube plus 2x plus 3 and రాసాను కదా, so you can write it as, so by seeing the coefficient of vectors. So if you wanted to represent that in a form of coefficient of vectors, so then definitely you need to follow first the finding of the coefficients. Okay, so the real expression is x power cube x cube minus 1.5 x square minus 5.5 x plus 3. Okay, so now you can see here the order x power 3, x power 2, x power 1. Okay, and this will continue as equation అలాగే వస్తుంది. ఓకేనా, 3. సో ఇప్పుడు మనం ఈక్వేషన్స్ మాత్రమే తీసుకుంటాం. 1, 1.5 minus, so here also we need to consider minus 1.5 and minus 5.5, 3. So we will create a vector like this. Okay, so we will create 1 minus 1.5 space 1 minus 5.5 space 3. So this will consider the expression like this. Okay, so manaki expression తెలుసు, but MATLAB will deal the expression, polynomial expression, in this way. Okay, అర్థమైందా? Is there any doubt?
No, ma'am.
No, right? Okay, so if you wanted to create the polynomial values, okay, so by creating line space,